Okay, so let's just take a little sideways step here and talk about matrices. All right, matrices are an array of numbers or a set of numbers, and the array or the set is made up of a row of numbers and a column of numbers. So obviously, a bit like a spreadsheet. There's my row, and the first digit there, the 1, A1, 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 and my column 1, column 2, column 3, column 4. So let's use this, say that element there, A24, represents row 2, column 4, okay? As in that one there, A34. So it's just a grouping of numbers or sets of numbers, if you like, all right? Now, go back. The dimensions or the order of the matrix, we need to talk about that, okay, is determined by the number of rows and the number of columns. All right, so for example, if I have 1, 2, 3, 7, 6, 4, the order of this matrix is the number of rows, which is 3, by the number of columns, which is 2. So it's a 3 by 2 matrix. All right. The way in which we manipulate, add, subtract matrices is a little bit different. All right. First things first, I guess we should. So then when we go to add and subtract matrices, we can only add and subtract matrices of the same order. All right. So that's that statement here. Only occurs when the matrices are of the same order or the same dimensions. All right. So in here, A plus B is simply we add the corresponding elements. So A11 plus B11 is 2 plus 3. 6 and the 6 are both in corresponding points. -1 plus 1 and 3 plus 3. Yeah, so we add the corresponding points. So A plus B in matrix form is just 5, 12, 0, 6. All right. If I want to multiply by a constant, I just multiply that value into everything. So 3 times A means 3 times 2, 3 times 6, 3 times -1, and 3 times 3, which is equal to 6, 18, -3, and 9. Then obviously something like 2A minus 4B, we just evaluate 2A, evaluate 4B, and subtract them. So we might go, well, that's equal to, what is 2A? 2A is 4, 12, -2, 6. We're going to subtract 4B. So what is 4 times B? Which is 12, 24, 4, and 12. And so then if I subtract them, I get 4 minus 12, which is -8. 12 minus 24, which is -12. -2 minus 4 is -6. 6 minus 12 is -6. So I could leave it like that. Hopefully I can see there that I could take a common factor out. So -2 is common to each of those terms. And that will give me a +4, +6, 3, +3, +3. All right, so that's our basic matrix addition, subtraction, multiplying by a constant. All right. Okay, if I want to multiply two matrices, it's a little bit different. All right. So the key element here is, and it's confusing to describe, but it's easy to see. So when multiplying two matrices, the number of columns of the first matrix must be the same as the number of rows of the second matrix. All right, and there's a few little little interesting tidbits there. So what I'm saying is, if I've got a matrix 2, 1, 3, 4, and I want to multiply that with the matrix 2, 1, 3, 6, 4, 2, what I'm doing is I want to check the order of this matrix is 2 by 2. The order of this matrix is a 2 by 3. All right. For multiplication to exist, these two numbers must be the same. So that 2 there, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. So those two have to be the same for us to multiply. So if I reverse the order here, 2, 3, 4, 1, 6, 2, and I want to multiply 2, 1, 3, 4, this is a 2 by 3, and this is a 2 by 2. These two matrices can't be multiplied. So straight away, that should tell you two things, or one thing in particular, that the order that you multiply the matrices is very important. All right, because the same two matrices, I can multiply them and evaluate it in one order, but I can't evaluate it in the other order. All right. So you check the middle two numbers to see if you can multiply them. If you can, the end two numbers tell you the order of the matrix that you create. So this multiplication will generate a 2 by 3 matrix is the answer. All right. This one doesn't work, so it doesn't generate anything. So let's have a look at how we multiply them. So let's check to see if we can multiply. So let's expand this up a little bit, give me a bit more. So this matrix is 2 by 3. This matrix is 3 by 4. So they're the same. So yes, I can multiply them, and I should end up with a 2 by 4 matrix in return. All right. Now we'll probably go through, we need to go through the multiplication just to see how we do it. So to actually carry out the multiplication, we can describe the process of how to do the multiplications as rows by column. So let's just try and, there's my green matrix. There's my blue matrix. So in fact, what might be better is let's concentrate on this row and that column. All right. And so what we do is I'm going to go multiply this row of numbers by this column of numbers. So I sort of, if you like, turn this row of 1, 2, 3 and make it a vertical 1, 2, 3 and multiply. So I'm going to go 1 times 1, and then I'm going to go plus 2 times 2 plus 3 times 3. All of that is the first element in my matrix. And then I'm going to multiply that row by this column. All right. So maybe to make it a little bit more color coded, let's leave everything in that column as green. And so now we're going to make our way to red. And I'm going to say 1 times 2 plus 2 times 0 plus 3 times -4. Yeah. Then I'm going to go to these numbers, the same row times this column. So that'll give me 1 times 3, which is, oops, undo that. It's going to give me 1 times 3, which is 3, plus 2 times 1, which is 2, plus 3 times 0, which is 0. Yeah. And then finally, I'm going to do that column of numbers. And I'm going to have 1 times 4, which is 4, plus 2 times 6, which is 12, plus 3 times 8, which is 24. I've got no more columns, so I finish. And now I do exactly the same process with this row of numbers. So I'm now going to go new row, 2 times 1, 4 times 2, 5 times 3. So I'm going to go 2 times 1 plus 4 times 2 plus 5 times 3. Okay? And now I'm going to multiply the red numbers. 2 times 2, which is 4, 4 times 0, which is 0, 5 times negative 4, which is negative 20. Multiply the blue column of numbers. 2 times 3, which is 6, 4 times 1, which is 4, 5 times 0, which is 0. Multiply the black column. 2 times 4, which is 8, 4 times 6, which is 24, 5 times 8, which is 40. No more rows to do, no more columns, so I've finished. So let's just close our matrix over a little bit. So now that becomes 1 times 1 plus 2 times 2, evaluate this line, plus 3 times 3, which is 9, 13, 14. Evaluate that element. So 1 times 2 is 2, plus 0 minus 12 is negative 10. 3 plus 2 plus 0 is 5. And then 4 plus 12 plus 24 is 40. So that's the end of that. Come down to the second row. 2 plus 8 plus 15 is 25. 4 plus 0 minus 20 is negative 16. 6 plus 4 plus 0 is 10. And then 24, 40, and 8 is 72. All right, so that's my resultant matrix. Notice the dimensions of this matrix is 4 rows, 2 columns. Get that right. 2 rows by 4 columns. So it's always row by column. So there's the dimensions, which is what we thought we would get over here. All right. So you just got to take your time with the multiplication process. All right. What about this matrix here? This is a 3 by 3. And this is a 2 by 3. These two aren't the same, so we can't work it out. All right, so there's no solution for that. All right, so have a good look. Take your time going through 7E. Just do that multiplication process nice and slowly.